Very good afternoon to all of you. Welcome you guys. Welcome you all. Yes, first of all, do comment करके बोलिए now. Is the audio videos clear to everybody? Yes, chalo. And so first of all, welcome you guys. Welcome you all. So in this session, we are going to discuss the previous year SSC JE, EEE, like a Transco, Genco, and this power sector jobs, all type of the important questions and the previous year questions we are going to discuss. And this will be helpful to all the students who are preparing for state government exams, SSC, JE and AE, AEE exams के लिए a course both काम आएगा. So we are discussing these courses, and this is the part 5. So the student who has missed the previous classes, you can watch the previous classes also. Now I'm planning to discuss the networks, digital, signals, controls, EMFT. These 5 subjects I'm discuss. All the previous year questions will be covered. Okay. Along with this, and the most expected questions for SSC, JE and राजस्थान पब्लिक सेक्टर जॉब्स के लिए भी ये बहुत काम आएगा, CIL को भी. And first of all, so great news to the aspirants who are seriously preparing for 2027 GATE के लिए. Now the unacademy subscription, that is just to 7,999 only. And this 180 days of this preparation will change your complete future. Okay, start your serious preparation and you will get 6 months plus additionally 1 month का benefit आपको मिलेगा. So as per the request on the student, the offer has been extended till 29th July. So to enroll for it, you can use the code of BV Reddy. Use the code of BV Reddy and to avail these opportunities and to have the great learning experience. Right. This is one of the greatest opportunity. Try to utilize. Now you can see the top educators of an academy आपको एक साथ मिलेगा. So this is the last live batch is starting from the 24th July से शुरू हो गया. So do enroll for it immediately and have the great learning experience. And 24th July onwards नया बैच शुरू हो गया with the control systems and the network analysis. Right, this is for 2028 के लिए भी नया बैच शुरू हो गया. So MahaSangramam, so the test series for the electronics engineering. So this now the test series MahaSangramam for the test series for electronics engineering, that is just 1499 only. So you can use the code of BV Reddy or we can use the code of BV Reddy and to have the great learning experience. With the test series, you will get to know where you stand in the entire India from all the aspirants. Totally how many tests we are doing here? 73 tests and computer based test only. And so it is exactly like a real GATE exam. And this exam that is curated by the top educators of an academy. Now these are the rankers of GATE 2026 rankers from Unacademica. ESC rankers, you can see now these many rankers are there. You can have a look at now. So many rankers are there. Right. And what we offer now, we offer the 2 subscription plus वाला, iconic वाला. Plus में आपको क्या चीज मिलेगा? So you will get top educators classes, live dots होगा, evaluated test series, structured courses, live test, unlimited access. Iconic में additionally personal coach भी मिलेगा and physical notes also you will get. So you can start a serious preparation with this. Yes, the test series. The test series, I think you need to evaluate separately. Start your serious preparation with the Unacademy so you can achieve your dream goals. Let's crack it. So, chalo, let's continue our discussion. And the last class, how many problems we have completed? You tell me. How many problems we did? How many? So we are doing the problems now. How many problems we did? If you remembered the number of problems, how many we have completed? Remember the number of problems what we did? How many we did? Right, 60 we have completed. Right, and we'll continue the remaining problems now here. Take the next one. An ideal ammeter is connected between the terminals A and B. Terminals A and B, the reading of the ammeter is where the ammeter is connected between A and B. So we need to find the ideal ammeter. What is the ideal ammeter? Will measure the short circuit current. Ammeter will measure what current? Short circuit current. So that means, so here we need to find the short circuit current. We need to find. So tell me now here these connections. If you redraw the circuit now, so you can see how it could be a. Now this is 9 volts and this is 6 and this is 6, 6 and this is 6. And so this is ammeter which is measure the short circuit current which we have shorted now here. We need this current we need now. So here shorted now here this is the dead element now there is no flow of current. So this element we can remove it now. So this there is no flow of current, short path is there, and you can see what will be the equivalent resistance of the circuit now here. R equivalent 6 6 parallel 3 9. So this value how much now? 9, isn't it? So from this can I get this current now? This current is I. So this is I is equal to how much now? 1 ampere. So here this current which is 1 ampere, after coming here, now the current will divide between the two paths. Now tell me now. So in this direction, current will divide equally. So that means what is this current? We can say now this is 1 by 2 amperes and this is 1 by 2 amperes. So this is I is equal to how much now? You can say now 1 by 2 amperes. This is 0.5 amperes. Okay. Next one. In the circuit shown, the dependent source is. What the dependent source will do? It will deliver or absorb that how much the power. So look at now here, V1 is 20 given. So how much this current is a? 20 by 5, which is equal to 4 amperes. So that means this current is 4 amperes. Yeah, so this current is 4 amperes. Now, what we can do here? So we need to get the voltage across this element we need to get. So if I call this voltage is a something Vx, we can use a nodal equations now. Tell me now here Vx minus 20 by 1 plus Vx by 1 and which is equal to entry current is 4. So we can get Vx that is 2Vx and which is equal to 24. Now the Vx equal to how much now here? 12. Vx is 12. So this voltage 12, that means this voltage is also 12 volts only. And this voltage is also 12 volts only. So from this we can able to get the power now. So this power which will be equal to V1. So this is 12. Voltage is at 12 and current is what, tell me now here? 4, which will be equal to 48 watts. And here where is the current is coming now? Current is entering at the negative terminal. So this element is what it is doing and delivering and absorbing. So this is delivering. Delivered. So what's the option you tell me now? Option B. Right. Then next one. The current in the 1 ohm resistor in the circuit is current in the 1 ohm resistor. So this means this voltage which is equal to 1 volt only now. So we need this current, right? How much this current you can see now here? So this is 1 by 1 which will be equal to 1 ampere. Right? Then next one. The current I in the circuit is, so we can use the nodal now here. So if I call this voltage is Vx, tell me now here Vx value we can find. From that we can get this I value. Tell me now Vx is a, so we can write Vx minus 10 by 2 plus Vx by 5 and which is equal to 5 entry current. So tell me now here Vx we have taken common, that is 1 by 2 plus 1 by 5 and which is equal to 5 plus 5. 5 plus 5, 10. So that is Vx which will be equal to 5 plus 2, 7 by 10. 7 by 10 which will be equal to 10. So that is Vx value will come to be what, tell me now here, 100 by 7. Vx value which is equal to 100 by 7 volts. Yeah, from this, can you tell me now this I value? I is equal to Vx by 5. So this is 100 by 7 into 5. So this I value will come to be a 20/7 amperes. This is option. Next one. The value of resistance between the terminals A and B is changed to 5 ohms. The compensating voltage is, okay, they given this as initially we have 3 ohms. Now they change it to what, tell me now? 5 volts. Then what will be the compensating voltage they ask to find? So, yeah, you tell me now, first of all, when it's 3 now, so we can get the, when the resistance R, if I say when R is equal to 3, so we can get this current now here. So that is equal to 8/4, which will be equal to 2 amperes. Okay. Now, what they're saying here, now this value change it to how much now? Voltage. So they change it to some other 5 volts. So we need to find the compensating voltage. That is delta V we need to find. So the delta V, which will be equal to what, tell me now? This is I into delta R, compensating voltage. Compensating voltage, which will be equal to what, you tell me now? Compensating voltage. Initially, we have a current is there, same current has to be maintained. That is delta V, which is equal to I into delta R. So that is how much is delta V now here? I value 2, delta R, final value 3, initial value 2 now. So this value, how much the delta V compensating voltage will come 2 into 2, which is equal to 4 volts. This is the compensating voltage. Right. Next one. The impedance of the circuit is given as like this. They ask him to find the power factor. Yes. Power factor impedance is given. How we can get the power factor of a circuit? You tell me now. This is the power factor impedance Z, which is given as what we can say now 4 plus J3. The impedance power factor, which will be given as power factor. So this is PF, which is given as real part by mod Z. So that will be given as what we can say R is 4 by mod Z value 5. So this is nothing but 0.8 now. Here whose effect is the inductance effect or capacitance effect? Inductance effect. Inductance effect I thought, so that means what we can say now lag. So that is 0.8 lagging. So now next one, which are the following quantities is dimensionally different from the other three? Dimensionally different from other three. Okay, let's find one by one. So here, first of all, they given this first one, they given this as L by R. If we remember, this is a time constant. Time constant is L by R. So these units are what we can say now seconds. Next, second option, that is RC. This is also time constant only, tau. So this units also what we can say now seconds. And option C, this is omega L by R. This is what you tell me now. This is the, so this is frequency. So this is the quality factor. Basically, this is what tell me now quality factor. So these dimensions. So if we see carefully, So this dimension which we have, this is radians per second into second. So then this will come to be what will be now radians will come. Option D, this is 2 pi by omega. This is nothing but time period only na. Time period, these dimensions are what you tell me now seconds. So that means this has a different dimensions na. Omega not L, omega L by R. These dimensions are different. Next, the equivalent resistance in ohms in the circuit is, okay, they given the 2s and this 4s. That means this is what they given, you tell me now. This is given, it is in a Siemens. Means what, tell me now. Most they given, conductance is given. So if we call this a G1 and this is the G2, which is given as 2 Siemens and this is 4 Siemens is given. Now how these two are connected, you see this thing. How these two are connected in series, they connected. How these two connected in series. Now what the equivalent value, that is 1 by G equivalent, which will be equal to 1 by G1 plus 1 by G2. So that is 1 by G equivalent, which is equal to 1 by 2 plus 1 by 4. Then how much this value, tell me now, which will be equal to 4. So this is 2 plus 1 by 4, which will come to be what, tell me now, 3 by 4. This is 1 by G equivalent. 1 by G equivalent is 3 by 4. And what now they asking to find out here? This is G equivalent. So here the G equivalent will come to be 4 by 3. This is in Siemens. But they asking in the ohms form, they asking that is R equivalent, which is equal to what, tell me? 1 by G equivalent. So that means which is equal to 3 by 4 ohms. So option C. Okay. They given most, they given. Next, when the total charge in a capacitor is doubled, the energy stored is charge, what happens now, doubled. Then what happens to the energy? Capacitor. So that means energy of a capacitor U, which will be equal to Q square by 2C. Yes, so that means how the charge proportional to the energy proportional to charge now, Q square na. So that means what happens now here, that is we can say now U1 by U2, which will be equal to Q1 by Q2 whole square. Then they given this as charge Q2 is given as what will be now 2 times of Q1. So that means U by, we can say now U2, which is equal to, that is Q1 by 2Q1 whole square. So that is given as U by U2, which will be equal to 1 by 4. That is U2 equal to what, tell me now, 4 times the U na. So this is, the energy is quadrupled. So this is the option. Next, KVL is based upon the principle of, KVL is based upon law of conservation of energy. KVL is based upon law of conservation of energy. KCL is, so here KCL is based upon what, tell me? Law of conservation of charges. KCL is law of conservation of charges. And KVL is law of conservation of energy. Okay. Next one. The current in the circuit is. So let's see this thing here. I naught. So then this voltage, which will be equal to 4 I naught. So let's write the KVL in this loop now. Let's write the KVL in the loop. So we'll commit as what element of 4 I naught plus 5 I naught minus 36 equal to 0. Then we have this as 9 I naught, which is equal to 36. Fine. So that means I naught equal to how much now? So this is 36 by 9. How much now? 4 amperes. Okay. Then next one. The dependent source in the circuit shown is classified as what we'll call this dependent source. You tell me now here. This is the dependent source, which is called as what type of source is a? This is basically a current source. Basically, it is a current source, and this value controlled by voltage across this resistor. So that means this is called as what? Tell me now. Voltage controlled current source. What we'll call this is a voltage controlled current source. Okay, so this is voltage controlled current source. So what's the option? First option. Next, which of the following is true for the Fourier coefficients of odd functions? So this is the signal system. Fine, we'll do. Also, this also will do. Odd function. The function is odd. Now, odd means I told you, I asked you to remember this OBS. Odd means remember OBS. Odd, observation, like we can say observation book. So here odd I thought, so it is if the given function is odd, then it will contains a Bn terms. It will contains Bn terms. And what else? Bn and sine terms, we can say. So let's see now here. What terms will contains the odd function? It will contains only Bn terms only, should not contain An terms. A not 0, it is contain only Bn terms only will contains. Bn terms only non-zero. Only Bn terms are non-zero, remaining values are zeros. So this is the option. Right? Next. Which of the following function is not an even function? Which is even function? If the power is even number, even function. So t square, this is the even and odd. So this is an even function only now. And the t power 4, this is also even function. And here which is even function? Sine and cos. So cos is even function, remember. So cos is even and the sine is an odd function. So this is, we have f of minus t. If it is equal to f of t, then we can call, then f of t is even function. F of t is called as the even function. Okay. And which is even function, you can see now. So this cos 𝐬𝐴, you might be seeing cos of minus theta, which is equal to cos theta. You might be heard. That's why cos is a even function. But sine of minus theta equal to what? Tell me now. Sine of minus theta equal to minus sine theta. So sine is a odd function. So here this is an odd function. Cos is the even function, remember. Next one. The sawtooth waveform has a period of t and maximum value of ym. The RF, and do remember, in case of a triangular wave and sawtooth wave, the RMS value for the triangular wave and sawtooth wave, and do remember, and which will be equal to the peak value V0, that is V0 by root 3. So here they given maximum value Ym is something given, that means we can say now this is Ym by root 3. For in case of a triangular wave and sawtooth wave, RMS value is how much? So which will be equal to Ym by root 3. This is same for the triangular as well as a sawtooth wave also, remember. Next. Read the statements P and Q and pick the correct option. An inductor acts like a short circuit to DC. Yes. Inductor behave like a short circuit. Yes or no? So the inductor, so impedance of inductor is how much, you tell me now? ZL, which is given as J omega L. So that means for DC, omega value 0. So that means impedance of inductor will come to be 0. So 0, impedance is 0 means we can say short circuit only na. The current through a capacitor cannot change abruptly. Current through capacitor does not change. So here I is equal to C into dV by dt. In case of a capacitor, we can say now I is equal to C into what, tell me now? dV by dt. dV by dt. So the current through capacitor cannot change abruptly. So will there is any sudden changes of voltage will happens? In case of a capacitor, voltage does not changes abruptly. Suddenly you cannot, within a 0 time, so there won't be much changes you can find now. There won't be much changes you can find current. So will this value changes now here? So this is current so here abruptly change. That means you see this thing here. Will the voltage will be changed immediately? Voltage. So will the voltage will change? No, it cannot change now. Will the voltage suddenly will become 0 to high value? Yes, within a 0 time. So for the current has to be changed abruptly. So in case of in case of this thing, voltage. So in case of a capacitor voltage initial voltage and final voltage same. We might be seeing for inductor. For inductor transient mechanism. That is what we can say now, IL of 0 plus, which is equal to IL of 0 minus. So current does not changes suddenly, abruptly, inductor. For capacitor is what, tell me? For capacitor, Vc of 0 plus equal to Vc of 0 minus. For capacitor, what happens now? Voltage does not change abruptly. So here, but they given current, they given, so that's why the Q is wrong statement. Only P is correct. Right. Next one. In a highly inductive circuit, a small capacitance is added in series. Okay. Then the angle between applied voltage and resultant current will be, and they are saying it as a highly inductive circuit. Highly inductive circuit. The angle between applied voltage and current. Angle means that is nothing but what, tell me now? Angle between the, that is phase angle. So they are saying it is highly inductive circuit. Let us consider the initially impedance of the circuit, which will be equal to R plus J into XL. J into something is there. Now in this case, angle, phi angle, which will be equal to what we have, tell me now? Tan inverse of, will come it as what, tell me now? XL by R. This is the initial angle, let us say phi 1. And after that, some capacitance is added. So whatever may be the capacitance, so here now the Z2, which will be equal to what, tell me now here? R plus JXL, because of the capacitance will come it as minus JX. Now tell me. Now, so that means Z2, which will come to be what, tell me now? This is R plus J into what we have, tell me now? XL minus X. Now this is phi 2. That should be equal to what we have, tell me now? Tan inverse of, tell me what we have, tell me now? XL minus X by R, isn't it? Now you tell me now, phi 2 is an angle. Obviously, XL minus X, because of that, so this value changes now. So that means this is phi 2 is less than phi 1, isn't it? So that means angle will decrease hoga na, tell me? Angle decreases. Next one. The charge on electron is known to be 1.6 into 10 power minus 19 coulombs. In a circuit, the current flowing is 1 ampere. How many electrons will be flowing through the circuit in a second? The number of electrons flowing through the circuit in a second we need to find. How many electrons are flowing we need to get. Yes. Now you tell me now, as we know this is I, which is equal to what, tell me now? Q by T. Now how many electrons are there flowing? Charge. So that means Q is equal to what we can say now? This is I into T na. I value given as 1 ampere. In T value given as 1 second. So charge is what, tell me now? 1 coulomb na. 1 coulomb of charge is crossing in 1 second. So as we know that charge is quantized. Q is equal to N into E na. N is equal to what term now? Q by E. So that is N is equal to Q. That is 1 by electron charge 1.6 into 10 power minus 19. So then simplify this thing, how much will come? So this value 10 power 19 by 1.6. So this value will come to be how much now? How much this value will come? Check it now. 1.6. So this value which I can write is 10 by 16 will write now into 10 power 19. We cancellations now here 2, 5, 2, 8. Okay. So that is 5 by 8. So how much is value? 0.625 into 10 power 19. This many electrons. Next one. Two bulbs. One bulb 250 100 watts. Second bulb 250 25 watts are connected in series. A 440 volts AC 50 Hz supply is applied across the two bulbs, what will happen? So first of all, we need to see the resistance of each bulb. So here, this is the bulb 1. The resistance of this bulb 1 R is equal to what we can say now. This is V square by P. V value, how much you tell me now? 250 into 250 by P. P value how much now? 100. So will come to be what we can say now? 625. 625 ohms. Now second bulb. Resistance of second bulb we can find. That is also V square by P only na. V square means here 250 into 250 by P value how much now? 25. Now 25 tens, which will be 2500. Now these two are connected in series now. These two are connected in series. So then these two are connected in series. In series connection, so this is R1 which is equal to 625 and this R2 equal to 2500. This is connected to 440 volts. Now tell me now here, in this case, current is same. Current is same means power. Power is given by what we can say now, this is I square into R. The power which is directly proportional to resistance. Here we can see now R1 is less than R2. So that's why P1 less than P2 now tell me. Whose power is more, you tell me now here. 25 watt bulbs power is more. 25 watt bulb's power is what? 25 watts bulb glows brighter compared to 100 watts. So this is option D. Next one. Three resistors, each of R, are connected in star. What is the value of equivalent delta connection? Star to delta conversions. So star, right. Star form. All the values are R, and this is also R. And these are connected in what form here? Start. Now we should convert the equivalent delta of this thing. So if I call this one is R1. So you tell me what is R1 now, tell me. So that is given as R plus R plus R into R by R. So this will come to be R will get cancelled. So how much will come? You can see now this is R1, which is equal to 3R. Each value will become 3R only now. Next, which are the following is a non-linear circuit parameters? Which is a non-linear circuit parameter they are asking to find? Inductance is a linear only. Condenser means capacitor. Capacitor is also linear. Wire wound resistor. Resistor is also linear only. And transistor is a non-linear. So that's why this is the option. Transistor diodes have a non-linear VI characteristics. Diode, transistor, diode, transistor, transistor. These two will have non-linear characteristics. Okay. Next one. An ideal voltage source. An ideal voltage source should have. Ideal voltage source will have a zero source resistance. Yes. Ideal voltage source has zero source resistance. And previously also we have seen, I think so, this point. Internal internal resistance internal resistance of ideal voltage source. Ideal voltage source is zero. Next, internal resistance of ideal current source is infinity. Okay. Next one. Find R3. Okay, resistance they ask to find R3 value. Yeah, you can see now here. Okay, they given 10 milli. This is 50. That means this current is 40 milliamperes. Okay. So now here, how much this voltage here? Positive, negative. How much this value? 100 into 10, so 1000. 1000 volt. So this voltage is also 1000 only. So that's why this R3, which will be equal to 1000 by 40 milli. 40 into 10 power minus 3. 0, 0 will get cancelled. This is 25. So that's why R3 will come to be what, tell me now? 25 into 10 cube. So that means R3 value is what, tell me now? 25 kilo ohms. So option C. Next one. Same, na? Same. A terminal where three or more branches will meet. That point is called as what, to terminal node. Where three or more branches will intersect, that point is called as a node. Next, two electric bulbs have tungsten filament of same thickness. If one of them gives 60 watts and other gives 100 watts, then what happens now here? Now they asking the different thing they given now here. 60-watt lamp filament has shorter length. 100-watt lamp filament has longer length. 60-watt filament has a longer length. Okay, two electric bulb have tungsten filament of same thickness. Thickness is same, means area must be same only. So basically the resistance R, which is given as what, tell me? V square by P. Resistance R is given as V square by P. So here how the resistance proportional to power, you can see now inversely proportional. So here we can see now P1. So P1 is P1 is less than P2. P1 is less than P2. Okay. That's why what happens now here, this is R1 is greater than R2 now. So that means resistance formula R is equal to what, tell me now? Rho L by A. Same thickness, rho also same. That means R proportional to L. R proportional to L. So that means what we can say, length proportional. So that means 60. 60-watt lamp has a longer length. So this 60-watt resistance is more, means length is also more only na. That's why 60-watt lamp has a longer length. Okay. Next, a 2 centimeters long coil has 10 turns and carries a current of 750 milliamperes. The magnetizing force means MMF, which is given as what, tell me now? N into I only na? Yes, so magnetizing force. Magnetizing force. So this is magnetizing force, which will denote as H and which will be given as N I by L. So N is what, tell me now? Number of turns is 10. I value 750 milli, 750 into 10 power minus 3 by L. Length is how much you tell me now? 2 centimeters. 2 into 10 power minus 2. Yeah, simplify and get it. How much this value will come? 2, 3. So this is 7, 5. Okay. And if I bring to this one, yes, so we'll get cancelled. So that is 375. That is ampere turns per meter. 375. So option D. 375 ampere turns per meter. Next. A magnetic circuit carries a flux of phi I in the iron part and a flux of phi G in the air gap. The leakage coefficient. How the leakage coefficient? If I denote this thing as a leakage coefficient is a K. So in air gap, iron flux is how much you tell me now? Phi I. So this is in the air gap is what tell me now? That is given as phi G. The leakage coefficient which is given as phi I by iron by air gap flux. Okay. Next one. 200 watt 200 volts lamps are connected in series across 200 volt supply. Okay, the power consumed by each lamp will be both lamp will have equal power only. Now. So that is how much the resistance of the two bulbs we can say equal resistance only now. That is R, which is given as V squared by P. V value how much now? This is 200 into 200 by power P value how much now? 100. So how much this value of R you see this thing? So this to this thing. So will come to be 400 ohms. Now these two resistors will have same equal resistance only now both are. This is 200 volt supply. This resistance is 400 and this is also 400 only. Now, so you can see now equivalent resistance is how much now? R equivalent, which will be equal to 800. And the power, which is equal to what, tell me now? V square by R. So how much this value? V value 200 into 200 by R value 800. Yes, we can simplify it now. 2, this is 4. So this is 4 5s and 0, which is equal to how much now? 50 watts. Okay, 50 watts. This is what tell me now here overall. But they ask each lamp now. Each lamp is 25. Total power is 50. And here this power across this one is 25. This one is 25. The voltage across 5 5H inductor is given as like this. Find the energy stored when at t is equal to 5 seconds, assuming initial current is 0. Okay. Energy we need to find. Yeah, so you can tell me now voltage is given. So we can get the current we can able to get now. So we know that V is equal to, that is L into di by dt. L into di by dt. This is a relation for the voltage and current in case of an inductor. So from this we can say now I is equal to 1 by L into integral of V into dt. So you can tell me now here, how much is value of I now? 1 by L value 5, integral of, they given us up to for what, tell me now? 0 to 5, 0 to 5 into, this is 30 t square into dt. So how much this value, tell me now? This is 6 into integral 0 to 5 into t square into dt. So this is, which is equal to 6 into what, tell me now? T cube by 3, limits 0 to 5. 2's now here. So this is I value which is equal to 2 into 5 cube. That is I value which is equal to 2 into 5, 125. So this means which is equal to 250. 250 amperes. This is the current we have. Now we need to get what, tell me now? Energy we need to get now? Energy. So this is energy E, which is given as of Li square, which is equal to energy, that is 1 by 2. L value given as 5. Current we have a 250 whole square. Tell me how much this value will become? $250 square into 2.5 I can write now. So 156. Okay. 156.25 kilojoules. Option C. Next one. Two wires A and B have the same cross sections. Same cross sections are made of same material. RA given 800, RB given 100. The number of times A is longer than B is. Tell me now, resistance formula basically, that is R proportional to L. Cross section same only na. That's why we can say this as R1 by R2, which will be equal to L1 by L2. So this ratios will be RA is 800, RB value 100, which is equal to L1 by L2. So this is, now this is L1 graph times A, which is equal to 8 into LB into L2 na, this much. So number of times A is no option at all. No option. No option is matching for this thing. Which is equal to L1 is 8 times. So this is, there might be some option, might be, it should be a 8 we need to have. Let us consider this one. R will make it this as a 8. And this is the option. Next one. Determine the voltage at point C shown below with respect to ground. With respect to ground. At the point C. At the point C, that voltage means that is nothing but voltage across 50. Voltage, this voltage we need now. If I call this voltage is V2. So you can tell me now how much this value of V2 you tell me now, which will be equal to 50 by, we can say now here 100, that is 150. 150 into 120. So how much this value will come here? 50 by 3s. Now 3/4. So that means V2 value come to be a 40. Next one. Find the current through 5 ohm resistor. Current through 5 ohm resistor. Here we can apply the current division CDR na. If I call this current is I2. I2 to resistor. If I want the current in 5, we should take opposite resistors in the numerator. That is 2 by 2 plus 5 into 10. So this value I2, which is equal to what, tell me now? 20 by 7. How much this value will come? 7 2s and here. So 2.85. Done. Next one. Total capacitance between the points L and M is equivalent capacitance. Right, first, how these two capacitors are in parallel will become 3. So 3 and 2 are in series. So 3 into 2 by 3 plus 2, which will come to be what I will now 6 by 5. 6 by 5 and 1 parallel. 6 by 5 plus 1, which will be equal to 11 by 5. 11 by 5 and 2 are in series. Means what, tell me now? 11 by 5 into 2 by 11 by 5 plus 2. How much will come here? This is 22 by, so this is 11 plus 10, which is equal to 22 by 21. Okay. And then this we have 1 is there here. Receive. Yeah, this is 1. Tell me now what we can say now. This is in parallel will be added. So that means C equivalent, which will come to be a 22 by 21 plus 1. Tell me how much will come. 22 by 21, this value 1.01 plus 1. So this is value how much now? Yes, 2.047 microfarads. So this we can take it as 2.05 microfarads. Option C. Next one. The BH curve for dash will be a straight line passed into the origin. BH curve for A is only the straight line. Remaining cases are curved now. BH curve for the A is a straight line passing through origin. Next, energy stored in an inductor is energy stored by the inductor, which is given as of Li square. Next, a coil with a certain number of turns has a specified time constant. If the number of turns is doubled, its time constant is. So, time constant, the time constant which is given as tau is equal to L by R. Okay, if the number of turns are doubled, if the inductance which is equal to mu, so here in mu n square L mu n square mu naught n square A by L. So this is mu naught n square A by L. This is the inductance now. So as the number of turns are doubled, what happens? You tell me now here. L proportional to n square, number of turns are doubled, the new inductance will become 4 times the initial inductance. And what about the resistance now here? R is equal to rho L by A, number of turns are doubled here, L proportional to N, so that means R proportional to N only now. That means R2 will become 2 times the R1. This is the initial time constant. Now the second time constant is what? Tell me now. This is L2 4 L1 by what? Tell me now, 2 R1. So this tau 2, which is equal to 2 into tau 1, become double. Next one. The flux through each turn of a 100-turn coil is T square minus 2T milliweber. The magnitude of the induced EMF is. Tell me the magnitude of induced EMF, Faraday's law, which will be equal to d phi by dt, and which will be equal to what? Tell me now. D by dt of flux t cube minus 2t. So that is EMF, which will come to be a what? Tell me now. 3t square minus 2. Now the given t value is 2 seconds now. So we can say the EMF now. That is 3 into 4 minus 2. That is 12 minus 2. Oh, they given milli given so 10 power minus 3. Sorry, they given number of turns also mentioned. So this is, we can say it as what n into d5 by dt. So n value 100, that is d by dt of number of turns, that is tq minus 2t Webers, that is 10 power minus 3. So that's by EMF, which will be equal to 10 power minus 1 into we have 3t square minus 2. So we'll put the t value is whatever 2 seconds now. So how much will come the EMF now? Which will come 10 power minus 1 into what tell me now? 3 into 4 minus 2 now. Which will be equal 10 power minus 1 into, so 12, that is 12. But why there is no option here? 12 minus 2, 10. Okay, 10. So that's why we can say this 1 volt. Okay. Next one. A circuit has an inductance 2H. If the circuit current changes at the rate of 10 amperes per second, then self-inductance is voltage across inductor L into di by dt na? Yeah, self-induced EMF. So this is induced EMF across inductor. Induced EMF across inductor. L value 2 into di by dt given 10 na? So this value which is equal to 20. Okay, so C, option C. Next one. For the network shown in the figure, the value of current in 8 ohm resistor. 8 ohm resistance. So first we'll find the equivalent resistance we'll find. So this one 12 and 8. How these two are series will become 20. 20, 20 parallel. So that means how much will be the R equivalent, you tell me now? R equivalent, which will come to be 10 ohms. 10 ohms, then the current given by the source. How much is I value? This is 48 by 10, which will come to be 4.8 amperes. Next, thereafter, this is 20, 20 equally will divide now. So this is 2.4 amperes. So this current is 2.4 amperes. Okay, done. Yeah, finally we have finished the 100 questions we have finished, right? 100 problems we have finished successfully. Now the student who has not attended the previous classes, do join the previous classes also. As I told now, so for this course, this is very helpful for the all state government public sector jobs के लिए बहुत important होगा, and SCC JE and so AE, AEE, GENCO, TRANSCO, all type of APPSC, TSPSC, all type of job this course will be very helpful. The problems, whatever we are going to see, all those are that level problems only. All of you do like the session and share to all your friends. Like the session everybody. So like that we do the same manner, will continue daily, will continue the classes. Isn't it? Okay. Okay, then see you. Bye bye.